Right, please make sure you have read this question before we start looking at the solution. I've drawn my tree diagram, putting all the information from the question onto the diagram. Because there's two stages to consider, it lends itself to a tree diagram. The first stage is whether the person has the disease or they don't, and the second stage is whether their test result comes back positive or negative. A positive test result suggests that they might have the disease, whereas a negative result suggests that they don't. Now, these tests are not perfect. Sometimes they give us false negatives or false positives, i.e. sometimes they suggest people have a disease when in reality they don't. So part A, find the probability that a positive result is obtained. Well, there are two paths through our tree diagram that lead to a positive result. Diseased and a positive result, or it is possible that a non-diseased person still gets a positive result. So those two paths are the ones we need for part A. Positive result, 0.02 times 0.96. That's if they have the disease. If they don't have the disease, it's 0.98 times 0.01. Both of those paths end with a positive test result, and that comes out at 0.029. In part B, we see the words given that. Given that a positive result is obtained, find the probability that this person has the disease. So this time we know the outcome of the test was definitely positive, but it's possible the person still didn't have the disease. So let's work out the probability of that happening. So first up, a general result, the probability of event A happening, given that event B has definitely happened. That is the probability of both events happening over the probability of whichever event we know has definitely happened. And that's in that formula, that's B. So applying it to our example here, the probability that the person has the disease, given that a positive test result was obtained, that's going to be the probability that they are diseased and get a positive result over the probability of whatever was given to us, and that's the fact that they got a positive result. Our numerator here is diseased and positive, so 0.02 times 0.96. And our denominator, the chance that they got a positive result, well, that was the answer to part A. Put that into a calculator and it comes out at 96 over 145, which is about 0.662 to 3 significant figures. So what that means is if somebody gets a positive test result, there's only actually a 66% chance they really have the disease. So roughly 1 in 3 people who get a positive test result don't actually have the disease. So maybe this medical test isn't a very good one if it's giving 1 in 3 false positives. Going on to B part 2 now. What's the chance of a positive result obtained if a second test is given to this person who also got a positive result the first time round? So I've extended my tree diagram here. A positive result the first time round, and then if they got positive the first time round, what's the chance they get another positive result? Well, if the person was diseased, then each time they take the test, there's a 96% chance of a positive result. If they did not have the disease, each time they take the test, there's a 1% chance of a positive result. So I want the probability that the second test was positive, given that we know the first one was definitely positive as well. So this is the probability of both things happening at the same time. It's the probability that the first positive and the second one also positive over the probability of what was given to us, and that's the probability that the first one was positive. Once again, our denominator is the answer to part A. So my numerator, first positive and second positive. So if they have the disease, it's 0.02, and then positive test result and another positive test result will be 0.96 times by itself. Or, so add, they do not have the disease, but then they get 2 consecutive positive results, which I can represent with that squared. Divide all of that by our answer to part A, and we get 0.639 to 3 sig fig.